My name is Sam Bose. I'm the founder and CEO of IntelliSense.io, and I'm delighted that you could make the time to join us today. Mining and metals industry is at a crossroads today. With the ever-increasing demand for minerals coming from every report that comes out every other day, we are looking at a minerals-driven energy system. While we drive for those demand, mining operations are already struggling with higher changing ore body, higher cost of extraction, while higher impurities, and a constant challenge of delivering additional net metal in a way that we don't scorch the planet. Computing technologies have a massive role to play to address and manage this delicate balance. With the advent of artificial intelligence and leading sensing technologies, for the first time, we are able to track material flows across the operation in real time. This will allow deploying new exploration and processing technologies while ensuring operational continuity and reducing the feasibility to commissioning cycle time. This is driving new players to join the industry, people who typically has been consumers of the metal downstream. Large mining and metals companies are deploying these technologies to transform their operations and deliver new business models. And they are looking to be the disruptor rather than be disrupted. We at IntelliSense are excited to support most of the mining majors across the 4 continents in delivering these technologies. Today, we will discuss how we, along with the technology, along with process chemistry, are building new tools that are allowing mining operations to manage this delicate balance. We will hear from the IntelliSense.io team about some of the work we have been doing for the past year, showcasing some of our new technologies that we are delivering as a part of our operations. And finally, we're going to talk about some new business models that real-time AI technologies need to adopt in order to make sure that digital transformation sticks within the industry. So our vision of AI has always been to be the best decision support tool for mining operators in order to create a safe, sustainable, and efficient operation. We have an exciting hour ahead of us. We have participation from our partners, from BASF. We got some demonstration from our product director, and we have our industry expert and industry guest in the form of Mike Anglin to discuss and have a fireside chat on how the mining industry needs to transform using these digital transformation tools. So welcome to Inspirations 23 again. With that, I would like to invite Karen Hoffman, Vice President of BASF Mining Solutions, to come and join me on this fireside chat. Welcome, Karen.
Thanks a lot, Sam. I'm very excited to be here at Inspirations 23, and I'm sure it's going to be an entertaining and interesting session for our audience as well.
Thanks, Karen, for making the time for our audience. Karen, we have been in the partnership between IntelliSense.io and BASF for 3 years now. I think our audience wants to know, what have you learned over these past 3 years?
Great question. I guess we learned a lot. So first of all, we learned that chemical and digital innovation are targeting the same thing: efficiency, basically getting more with less or more from less. So we are trying to make 1 + 1 = 3. We also learned that with this target, we are giving a big support to making mining more sustainable, because in the end, we are trying to save resources like water, electricity, also chemistry, while still producing more. The other big thing I think we learned is that there are lots of digital solution providers out there, and they all seem to be offering the same thing, but they're not. And it's very difficult if you are not in the matter, in the detail, to really understand where the different lies. So for us, it's extremely important to be able to very clearly show how we're different from everybody else.
Yeah, fantastic. I think that's one of the big things, because digital transformation has been in mining for close to 6 years now. And how scientific AI, which is the brand of AI that we measure on and we research on how it is differentiating over a machine learning driven model is something that I think we will explore a bit more today. Mm-hmm. So let's take us to the next question in terms of new innovations. What kind of new innovations you see BASF and IntelliSense.io bring to the market?
So let me talk about maybe 3 examples that I'm most excited about. Solvent extraction, leaching, and flotation. So we start with solvent extraction. I mean, the process has evolved over 40 years and it's quite efficient today. And the primary target has always been reaching a maximum process stability and also maximum extraction. And still today, SX operations rely very heavily on reactive management if a destabilization factor occurs. And with our SX application, what we can offer is we can offer proactive management of these destabilization factors. And that means we can give physical stability for the plant at any time, which I think is a fantastic way to increase efficiency.
Yeah, and I think in this inspiration, I can reveal that for some of our clients, our SX optimization application, joint SX optimization application, has seen up to 9% copper mass transfer gain, which is actually fantastic in terms of the amount of value that we can deliver without any capex. What are the other couple of areas that you have in mind?
Yeah, the next one is leaching. I mean, there's lots of innovation going on at the moment. So leaching oxides works very well. It's very efficient, but unfortunately only works on a very small part of the ore and it's depleting. Now, imagine we could efficiently leach chalcopyrite. And this is also where lots of companies are working on. And I'm convinced it's going to be different technologies that work depending on the mineralogy and the sourcing conditions. And our leaching app will help or helps to apply the right technology in the right place, in the right amount at the right time. That will make the leaching extremely efficient and effective. I think for me, that's a great example how AI and chemical innovation work together. And then down the line, potentially there's even going to be innovation for SX because depending on what's coming down your train, you may have to adjust the chemistry and potentially even the process.
Yeah. I think leaching is an exciting area, and this is another place where the value of scientific AI, which integrates data-driven models with the chemistry or first principle or physics-based models, brings the differentiator. And we are working on some pretty exciting projects in Latin America and Australia, and I think by the next inspirations, we will share some early results of that. What's the final area that you are excited about?
Yeah, the last one is flotation. Look, it's pretty cool. So if you buy your frother or your collector from BASF, we would have customized it to your specific conditions. And then if a small change occurs, like let's say a slight change in the feed grade, you adjust your processing conditions, but you do so reactively. Now, imagine you were licensing our grinding, stockpile, and flotation app, right? You'd be aware of these changes well in advance to when they occur, and you can proactively change your conditions. Now, the even more exciting thing is, if you have a bigger change, like, you're mining a different part of the ore body and the mineralogy is different, or you have a weather event that considerably changes the water quality, you may need a significant change in the chemistry you're using. And what we can do is we can use the data and we can feed it into the system and we can use it to adjust the chemistry. And it allows us to give you a perfectly adjusted chemistry to your new conditions much faster than in the, let's say, traditional way. And that allows you to generate more money quicker. Yeah.
I think recovery from flotation has been a real big focus for IntelliSense.io over the last year. And, we have developed a whole bunch of virtual sensors that can go down to the individual cell level and give you a view of the recovery. So that is quite an exciting area of innovation. Now, saying all that, there has been lots of implementations, as we talked about, of digital before. From your perspective, Karen, what do you see different from how we do it compared to the traditional way of implementing? What has changed?
So I think the big difference is, we've used a lot of, or all of our process know-how, the chemistry know-how, and the know-how of the chemical reactions that drive the processes. And with that together, we basically form a digital version of the process and of the equipment, like a digital twin. And then we find real correlations. And then we feed in all the data to prove the correlations. And it's a very robust system. If any change occurs, also major changes, or correlations are still correct, and we can perfectly predict what will happen and how the process parameters should be adjusted. The traditional way is more, taking data and finding correlations in the data. That works very well until major changes occur. Then also let's say the new system, right? The new way of doing things, it's faster. You have a basic model of the process, so you don't have to start from scratch every time you go to a new process or a new mine site. You just adjust what you have to the specific conditions of that process, and you have things running and up to speed much faster.
So great. For some of our customers and partners who are joining us, you are aware that one of the things IntelliSense.io have been very much focused on is building these digital process and digital asset models. So we have a library of those models, and what we've very much focused on is combining some of the first principle methods with the machine learning or data-driven methods to prove or disprove some of these correlations. So I think that's quite an interesting way that you can deliver value faster from these kind of AI projects. Now, finally, all these things, how does it play to the strengths of BASF, the partnership that we have?
I mean, as we mentioned before, right, we have this digital model of the process, and now the model needs to be configured to the exact conditions of the process. And the understanding that we have of these processes and the understanding we have of the chemical reactions that drive it, and also very often we know the mine sites very well. It allows us to together do the customization very fast. And the faster we can implement, the shorter the time to value generation for our customers. That's how I see the big value that we bring.
Right. One of the things you always look at is do a crystal ball so that we can come back maybe in the next inspirations and see where we ended up. So if you do a crystal ball, where do you see these kind of systems heading? Where do you see this? What's your prognosis?
Yeah, I see AI to assist us. Yeah, it'll help us to operate better and especially to make better decisions. So we want to balance throughput and recovery. And then at the same time, it'll allow us to reduce the input, the chemical use, the energy, the water. And so ultimately, it helps us to make mining more sustainable, but at the same time, deliver the metals that the world needs for the energy transition.
Great. Thanks, Karen. That actually takes us really nicely to the next section,
Thank
where
you.
we're going to talk about how IntelliSense.io has been building we're going to unveil or reveal some of our product features and functions, and some of the key uniqueness. So I would like to invite our product director, Mark Degaus, to come and join me on this session. Thank you, Karen. Welcome, Mark.
Thank you very much, Sam. Delighted to be here. As one of the founding members of IntelliSense, it's been quite a journey to get here. We've taken on some of, I think, the industry's hardest challenges, but I think our unique approach has resulted in unique solutions, and I think we've got something great to show people today. Firstly, I'd like to thank, obviously, the team who helped us all build this today at IntelliSense, but also our actual users and customers themselves. And so as a celebration to them at this Inspirations, we'd like to show off Brains app and our applications live in action across the world. You can see it here in multiple continents. You can see it here with multiple commodities. We have gold, we have copper, we have iron ore suggested here. I'd also like to show all the different roles that we have. We have geologists, metallurgists, all the way across our mining site. But also, I know a few of you are here today, and so thank you for all those users. You helped us build this fantastic solution for the mining industry. And so this has been built for miners by miners. And with that transition, I'd like to show you now the product that we use on the mine sites. So I'm going to share my screen and you can see it. And I'm going to just hide that. Perfect. Today, I'll be demonstrating 4 of our applications, predominantly the stockpile, flotation, grinding, and thickener app, all of which are available to you today. I'm going to present them in the context of net metal production and how they can all assist in balancing your throughput and recovery to enable a higher net metal production whilst sustaining your sustainability goals. We start with the slightly less glamorous part of AI, which is data and getting it, which is when we walk into many companies and their digital journey is the first hurdle. Simple questions like, I don't have enough data, my data is not good enough, etc. To do this, we've never had this challenge. We've never faltered at this challenge. Everybody has enough data and it's good enough. As you can see here, for a single asset, I'm now inside Brains app, all the data coming through for this particular common configurable asset of a SAG mill. You can see it coming through and all the quality features that we're pointing out here automatically. But naturally, this is not the amount of data points that a standard SAG mill gathers through instrumentation. This has been put through all of our virtual sensors, which transform this data into additional insights and additional metrics. Those additional metrics are generated in real time, and all of this is generated in real time from multiple data sources. We can integrate with over 20 plus mining systems, whether that be spatial data, laboratory data, time series data. Just to highlight a few of the types of virtual sensors we can do, which are broad, you can see some financial metrics, which we can calculate in real time. You can see, for example, residence times of SAG mills and different areas around the circuit. In terms of kilograms per ton inside, in terms of ball consumption, all of this can be automatically generated through our virtual sensors, and down to important metrics that we need to start generating and looking at in real time, such as the specific CO2 emissions of the SAG mill in real time. Now that we have all this data ready to go, let's look at net metal production. First thing we need to do is monitor net metal production before we can actually talk about it. And so net metal production is a combination of 3 things: the feed grade, the throughput, and the recovery. What I'm showing you here is 2 different aspects of looking at net metal production. If you look at the aspect from geology and mining, you almost predict the net metal production based upon the geology and the mining plan, which is represented in red here. So you can see the slightly bumpy way in which we get to a new block, we get to a new area, and we can see, and for those downstream, we expect the same feed grade, we expect constants here, versus the reality, which is the variability of the feed grade is actually quite high at a lower level. Most mines, as you can see, I'm looking at this at a daily resolution. Most mines can achieve this. Understand a mine plan based upon geology, what will my net metal production be? However, if you want, which is the hardest challenge in mining, 2 disciplines to talk to each other, mining and the plant, we need to get down to a lower resolution. And to do that, often what happens is our stockpiling, which is the interface between mining and processing, is often where data is lost, as we only look at volume and mass. However, let's fix this feed grade to ensure it's consistent and that it's predictable at a lower resolution. To do that, we'll introduce our stockpile application. The stockpile application gives you a high resolution 3D model of your stockpile generated as real-time data comes in. You can see here the formation of stockpiles obviously sped up in real time, but gives you an idea of the dynamic nature in which we're building these. You can also see that we can track brand new metrics that one would never think of using this methodology. For example, the age of each block here being tracked dynamically over time, blue being new, and then as you can see, taking that new material away, you could imagine splitting this in half and understanding older material and how it relates to oxidation. This is generated in real time and can be seen in Brain's app as generated. So now we have our feed grade, but however, we can zoom in now and look at this world at a higher resolution, an hourly resolution. So we understand this feed grade, it becomes predictable, and we can align better the mine and the plant. Understanding now getting the most out of what we put in is the next stage. And to go to that, we need to go down even a lower resolution into minutely resolution and the flotation circuit. In the flotation circuit, one of the hardest parts of flotation is not necessarily the lack of data, but the lack of instrumentation in the right areas to get you the right information. For example, recovery. Recovery is often measured through laboratory, and so is reported about 4 hours after the fact. And so decisions are made not proactively, and so therefore our recovery as a result suffers. However, using, again, our virtual sensors to get real-time recovery, real-time concentrate grade, tailings grade, and mass pull, we can monitor in real time and proactively make changes to ensure we maintain our targets. We can set up alerts to ensure that we make the correct evasive action well in time. But flotation is also at the lowest level important. It's all well and good looking at high level, but we still need to drill down constantly. And so you can see here the alerts that we can generate going down through luffers to cleaners to scavengers, and even down to the cell level, understanding where we are at each cell and what the optimum material characteristics are, for example, the P80, P95 and densities inside, and the recommended froth depths we can play with here to ensure that our recovery is maintained. So if we have a constant predictable feed grade, we have a high level of recovery, the next thing we've got to do is put more material through our circuit. To do that, we need to grind it efficiently at efficient energy levels. To do that, for example, offline, we could look at our grinding circuit simulation. As Karen alluded to, we developed digital twins. And so this is our grinding digital twin, fully configurable to your site. You can see here all the different variables that we can configure it to, whether it be the type of moisture of the feed, the actual microns of the feed, but also the effective setup of our piece of equipment itself in terms of height, diameter, etc. You can see here a similar representation of it. So if I simulate what's going to happen next offline using this material characteristics, I can see a full circuit mass balance in terms of all the particle size distributions, but predominantly I can understand the optimum throughput, 1,100 tons per hour, that I can feed through this SAG mill. If I reset that and I use the information from my digital stockpile, and I know that the material is going to be slightly smaller, I could simulate again and understand that I could get 100 tons more through my SAG mill at a slightly lower kilowatt hour per ton, lower energy consumption per ton. So what I've described here is a way in which we can consistently have a feed at the best recovery, knowing the best material character at the highest mass flow. Next, what we've got to do is, and I've showed you that in an offline setting and in a virtual sensor setting, real time. However, we need to optimize these things proactively, looking into the future. To do that, we're going to look at some of our sustainability metrics. So we're going to look at water. Water recovery predominantly takes place in most mines at a thickening circuit, where the water is separated from the solids, and often problems occur here with pushing these pieces of equipment to the maximum, and the torque of the rake often fails. Or in Karen's case, we use too much flocculant consumption in these areas. What I'm showing you here, and I think point out about the user experience, this is exactly what an operator on a mine sees. They see a different set of variables over time. But what they don't see is this 1 hour timestamp into the future and the predicted variables of the future based upon all the different material characteristics, based upon the state of all the assets before this, and the current running of that piece of equipment, including the uncertainty bands, which is about our transparent AI that we push at all times. From this, we can predict and optimize the future, right? Choosing a future we want based upon a set of value drivers. So you can see the change in the green control variables to achieve the optimum future in this case. Again, we have full transparency, and we can test out this digital twin and simulate whatever variable we'd like at extremely high speeds with incredible accuracy. But when I press that optimize button, right, what happens? Where are we optimizing from? How do we define the best? To do so, we have a configurable value driver for all of our applications. This is, knowing this, working on a mine site, aligning everybody to a common goal is one of the hardest things we can do almost in any business. However, we configure this, and this is some examples we've done with people on different mine sites about what they'd like to get out of each piece of equipment or each process. For example, maximizing sustainability, recovery, or throughput. If we look at an example of this, setting different variables up different ways will have a different outcome. Weighing flocculant consumption over recovery will reduce costs, or understanding how much water we get out versus the throughput will help our sustainability goals. The power of AI allows those decisions to be made and that balancing to happen for us. Once those decisions have been made, probably one of the hardest parts of any AI transformation is getting people to follow and trust and use AI. And so with that, we have developed a simple to use screen where we can deliver the recommendations to our final user, our operator in this case, as to what the recommendations are and how to follow them. But transparency is everything here. And for example, I've got 2 thickeners. You can see one is in full operation and the second one is not giving me recommendations. I'm not forcing the recommendations because I've poor data quality in this case. Nobody wants to hear a recommendation with this kind of data coming through. However, the transparency is always there. And if required, this, with training, one can understand how to read what is going on inside the optimizer's brain. And so that's presented at all times to our final users. So this together will have a high benefit on our process, but we obviously want to track those benefits and present them back, how AI has affected our process. And so today's theme was about net metal production and the balance between recovery, throughput, and how our set of applications can help on the bigger scale. To do that, again, we need to track everything if you want to report on everything. And so, for example, net metal production can be reported almost at a minutely scale based upon your production, but also different sustainability variables, such as the kilograms of CO2 per net metal production, can be reported almost on a minutely scale. And so decisions on a mine amazingly can be made based upon what is happening right now to our environment. If I summarize, and this is a culmination of all the data that we've seen today, before IntelliSense, with IntelliSense, and some of the benefits, the feed grade in this case, using our stockpile app, will remain the same. However, the predicted downstream variability will improve. There's a very small variability here, but we do have a higher variability of predicted downstream. So we understand our feed grade better. Using that, we can increase our throughput. In this case, the optimizer or the value driver for this site has identified that recovery may go down in the higher case of the throughput. But it's about balancing in this case to ensure that, for example, our net metal production goes up. So by 10%. In terms of the thickener, we can make a giant improvement in the underflow percent solids with this throughput and recovery, and understanding that we need less fresh water being pumped to our mine. As a result, we probably use the same amount of energy in this case. However, because we've produced more metal, we're producing less energy per net metal produced. As a result, if we look at how that converts into our sustainability metrics, our CO2 per kilogram of net metal produced is reduced by about 10%. The recycling rate of our water goes up, and our fresh water per kilogram of net metal production also goes down by 11%. Overall, being able to use our applications to balance everything within your circuit, from the material coming in and making that predictable and understanding the best way to process it, will help our planet and the sustainability goals of any mine. So I'd like to invite you to come and talk to IntelliSense about how we can configure this solution to your mine. So with that, please, back to Sam.
Great. Thank you, Mark. That was amazing. And I think that kind of demonstrates some of our thought process on how we see AI getting applied in mining operations at an unit process level, but how we are able to bring it together at an overall system level. Now, without further ado, I would like to bring Mike Anglin on board with us for our fireside chat with him. Thanks, Mark. Mike has been is an industry expert and luminary for some time with us, and maybe Mike, you can introduce yourself to the audience, and we go from there for our conversation.
Great, thanks, Sam. Delighted to be invited to Inspirations 23, and I must admit, thank you, Karen. It was really good to hear what you guys are doing at BSF. Mark, always exciting to hear your talk, and thanks for that presentation. I think just a little bit of background. I sort of frightened myself the other day. I realized I've been in the industry a long time. I started off working underground as a miner, ended up doing most of the jobs that you could do at a mining company, from business development, strategy, general manager of mine operations, COO of a group of mines, been involved in construction. And probably the most challenging job I had at BHP was to help develop and implement the operating excellence program across the company. We started that in 2000. And I think what drove it for me was probably the most important thing. It was about just empowering people with the right training and tools to work safely and just do the best they can every day. And I think that's why I'm really interested in what IntelliSense has to offer. I think this is a way of helping everybody in the industry. And I think, as everybody said, we are in a more complex world. It's great that there is demand for our products, but also the challenges have also increased. And it's a capital-intensive business. We really need to make the best use of what we have. At the same time, do it in a safe manner. And I think a lot of these tools enable people to take some of the stress out of the day-to-day operations. So anyway, thanks, Sam, and thanks for the opportunity.
No, thanks, Mike. To maybe we get started with our conversation, from your perspective, just to get some basic terminologies explained for the first question, which is, how do you look at what typically the mining industry have used? This is the typical software, which is known as system of records, and this kind of new breed of AI powered or AI driven, what we look at source of truth systems that are coming out.
Yeah, I think it's good to get some of the definitions so people are clear on them. I mean, when years ago, when we were starting in the development and construction phase of Escondida, we were generating massive amounts of data, and that was really just system of record. It was all the historical data that had gone through the feasibility study, the geologists had devised, and then as we system up and running, we had the very first basic accounting systems and all that sort of stuff, and that really was just user-led data entry. It was just a record. It was really just a digital file of what we've done. And then I think as we started to use all the sensors and all the sort of real-time equipment, we started to build up a lot of historical data. It was sort of near real time. So, maybe for the previous shift or the previous 6-hour period. And this was from a lot of different sources, not always reliable. And in the end, for many years, we've been sort of running the business high speed in one direction while looking in basically looking in the rearview mirror. And so I think this is where AI has this great opportunity to create a new category that really feeds off this real-time data that's coming through, and also all the historical data, because we spent a lot of money to get that. I think it's important to keep using it.
Yeah.
The idea is we use those two and create what we're calling operational intelligence, which is both predictive and proactive. And I think that the key for me is that it will now assist mining operators to run operations based on the prediction of what's going to happen, not what has happened. The other part of this is operational intelligence allows humans to make real-time operational decisions as they look at the future state. Then it gets more complicated nowadays because you're adding in all the other contextual operating conditions that's been mentioned before. You want to optimize your water consumption, optimize your energy consumption, and so being able to put all that into a format that you can understand, I think, is fantastic.
Yeah, great. And one of the things we also found was that there is a lot of historical data that is already there, and there's a data that is constantly being generated. So the ability to predict and then take actions based on certain targets that the mine has set is quite an important requirement. And that kind of takes us to the next question that I had for you, which was, why do you think these kind of source of truth or AI powered systems need a different approach? And why is it more challenging for the mining industry specifically compared to a lot of other industries?
Yeah, thanks. As I mentioned earlier, we are a capital intensive business, and we've invested a lot in getting the right sensors, getting the right data. And at the same time, we have to evolve as we've got these challenges, as we've mentioned before, reducing the carbon footprint and improving our water usage. But the other thing that you see every day in the mining industry, which for me is one of the key evolving issues, is we have this talent shortfall in finding and retaining people who have the skills needed for the day-to-day operational management of these AI systems. So I think one way is to optimize the way it works so that we can use the data to make dynamic operating decisions, and at the same time represent the changing operating conditions, and also take into account how we manage the human variability, which certainly most people have operated big mines, so it's a big factor. And as has been mentioned, the AI systems are a digital replica. So and the nice thing about them is they have both the physical modeling and the data modeling, but they do need regular retraining and performance tracking to act as a sort of a single source of truth.
Yeah, I think that's one of the things we find, and also because the other interesting part of the interesting question that I have for you is, these AI systems are delivering real-time predictions, and that's in the real world, and this is very different, as a ChatGPT-driven large language model predictions. So, so on that basis, how do you see these kind of systems? What is the requirement from an operational risk perspective?
Yeah, I think that, I mean, the biggest issue for me from a sort of a governance perspective, going sort of up to 30,000 feet, is, if the system's not working and we get it wrong, it has massive consequences for the operation. And some of these operations, some of the unit operations are not particularly stable. So if they go out of control, it takes them a long time to get back in control. So I think one of the key factors is just building trust in these feed forward systems. We've done the work, we've built the models, we've got the physics and numerical models, but we still need to make sure that every shift, every hour, every minute, we're using this correctly to deliver the accuracy and confidence we want. And the other thing is, you can build models and you can do all this work in the real operational world with the various data conditions. It all comes in, but you also need to be able to operate a scalable system, and also it has to have the proper failback systems. If an event occurs and you're not able to operate in the way you are. So you have to look at how people like Google operate. They're always there, and that's one of the challenges.
Yeah. And actually that takes us nicely to the next question, which is around, delivering these AI systems. Why do you feel a different approach is needed so that it can deliver value on a continuous and an ongoing basis to mining operations?
Yeah, I think, part of my history has been, especially when you're trying to implement any kind of a software system, is it's all great when you start the process, for the first couple of months. And then it seems to get hard. People change, the updates to the system don't go as smoothly. And so I think the traditional sort of software as a service delivery model that we're all familiar with now doesn't really manage continuous updates based on, the data dynamics changing, or the fact that the users are entering in, different metrics that they want to manage to. And the old model where you kind of, a bunch of people showed up, you implemented the software, there was a training session, you kind of handed it over to the operating team, really, I think, makes it unsuitable for a source of truth system. So, the key is the source of truth system needs to be in sync with the mine operations. We need to be reliable and predictable. And the minute anybody loses trust, then, basically that system is pretty much out of use. So I think, if you sort of follow the logic, to make it sustainable through its life cycle, you need really good data science, you need really good modeling capabilities, you need software engineering skills, good process knowledge, and finally, you need really good IT admin skills. I think when you put all these together in a package, it's pretty tough for most mining companies to have and maintain, especially with, as I mentioned earlier, the talent shortage.
Yeah, and I think one of the things we are also seeing is the industry is now opening up to that approach of managed software service. So how do you manage it? How do you deliver it for the industry? So what do you think from your perspective? What do you like about this model, and why is it relevant for the mining industry?
Well, I think one of the things we did learn from the pandemic was that we're much more comfortable working remotely, and companies are investing in these remote operation centers, and so really it's given them and us an opportunity to get best tools, skills that are available. And so when we talked about this earlier, we talked about Sam and I have talked a lot about the concept of the managed software solutions, where you have a subscription service that not only includes the implementation, but also comes with a dedicated team that in the background continues to monitor the software and make sure that the models are working as they need to model. And so I think that way the users can then get on with their job, which is consuming the output and making the operational decisions that they have to make. And for me, there's this good opportunity now with this managed software solutions model to leave the responsibility with the vendor, and so they're actually responsible for the updates, for the managing of it. And so the vendor can then cater to the changes in the processes, the data, the people, And they can do it nowadays, as as we're doing this webinar. It's easy to communicate across the world. I mean, the tools are in place. We need to use them. But the thing that's also good for me is that when you talk to guys in finance, guys in in the operating world, they would like to understand the true costs of these systems. And so I think if you end up with a what we're calling the managed software solutions, the costs are predictable. So as a CFO, as a mine manager, you know how much it's going to cost, and then it's also useful for them because they can then work out what the benefits are. It's costing me X, we're producing 10% more of X, and it's all pretty transparent. And then I think that makes people more relaxed, and especially from my perspective, I'm more relaxed if the best people operating in the background, we have them under a good contract, and we're paying them something that's appropriate.
I think that's quite a kind of a nice way to talk about it. Just to summarize, Mike, I think thanks for all your insights. It is really interesting to hear your perspective on, after seeing this digital transformation that has been tried in the mining industry for some time, why there is a new, different business model that is required. Just to for you to have the last word on this session, what would you like to close it with?
Well, I think firstly, really, this is pretty exciting. And I've been involved with IntelliSense for a while, and to see how you guys, how Mark and all the team and everybody has really worked hard to talk to the guys in the industry, to listen and to develop this suite of tools. So I think we're at the point now, and especially with the partners at ESF, where I think we can offer something that's of real value to the industry. And I think the delivery model that we've been talking about is something that will be attractive. I think it will do what we're all trying to do, which is make the industry more efficient and meet the pretty high level goals that we set ourselves.
Yeah. And from our perspective, IntelliSense, we're always making investment into our software infrastructure, into our people, into building new stuff. Innovation is a continuous game for us. And that's why we would like to become the technology partner rather than being just a vendor or a supplier to our customers. So with that, there are lots of questions that are coming through. So I'm conscious of time. So I would like to bring the panel back in and maybe share some of the questions that we are getting from the audience. So I would pick the first question. I think maybe it's to Karen. One of the questions from the audience is, do I need to buy BASF chemicals in order to have access to the intelligent mine solution?
No, you don't. You can just buy our intelligent mine solutions if you wish to.
Okay, great. The other question, which I think is coming is around it's for Mark, I would put it. How is the grind circuit simulator calibrated to the site? Is it 100% empirical modeling, first principle, data-driven, combination of both? What did you say?
Yeah, I've actually got a live answer as well from the team who are experts in this, just to clarify. It's a combination of both, as we use data from the live plant and physical principles to calibrate the system. So,
okay. I think I would add another question to that, which is the optimize function that we talked about, the control handles that we optimize. Do we have rights to change the actual parameters of the plant? For example, reagent valves or the air injection feed and things like that.
Correct. Yeah, I think that was a point that I actually missed. And so it's a great question and an obvious one. So the operator screen that I showed in the demonstration is an open loop AI, giving a human in the loop the ability or the opportunity to feedback and then put in the variables that we've outputted. Once trust has been built and the benefits are obvious, then at that point, we connect directly to the control system, allowing the operator to then go on and maybe even take on the next level of optimization that IntelliSense will bring. But no, it's completely closed loop after the trust is verified.
Okay. So I think there's another question, which maybe I'll pass it to Mike. Mike, one of the questions is around how does the boardroom or the C-suite in mining companies view these kind of system evolution, and how do they see impacting the mining operations of the future?
Yeah, I think at the board level, there's a lot of pressure from society to to improve our performance, basically, in terms of sustainability goals, water, greenhouse gases, whatever. And I think we've invested an enormous amount of money in the basic infrastructure, the operations, the sensors, the systems, and also the remote control centers. And so I think there's now an expectation that these start to deliver. And I put it that simply, that people are very excited when they see technology solutions that really aren't that capital intensive, that can leverage off our prior investments.
Okay. Yeah, that's a very good point. I think there is another question that maybe I will pass it to Mark. One of the questions is, do IntelliSense.io applications run well for many different commodities and different types of processes?
Yep. So each one of the applications, the word configurability comes up here again, is fully configurable on a set of modules. And so whether it be, if you take a grinding circuit, whether it be 1 SAG, 2 ball mills, 8 cyclones to process some copper versus a number of ball mills to process some platinum, it's fully configurable to, the models are fully configurable, and the solution is fully configurable to any commodity.
Okay. And there's questions of the time. So there's couple of other questions we can squeeze in. There's one question for maybe Karen. Karen, one of the questions is around the BASF expert services or expertise that is there. How do you guys see this in practice, working with AI or this kind of an AI technologies? How does this work hand in hand? What is your vision of it?
I mean, we have the process expertise. We understand the process, so we understand how the AI, how the apps work, how they help to make the processes more efficient. And with that, we can help explain how everything works, help the configuration, make sure we can, as Mark said, customize it as fast as possible, configure it to the conditions of the process. And then once it's running and once it's delivering value, if something doesn't work the way we want it to work or the customer wanted to work, we can come in and we can check out what's going wrong and, do service and support.
Okay, that's good. So one question, Mike, for you is, with your hat on of setting up operational excellence in BHP, what do you see is the future of the operational excellence discipline in mining industry with the advent of technologies with the advent of these kind of technologies?
I think what you see in a lot of companies is the operating excellence umbrella has grown. So technology has come under it. It's one of the tools in improving the business. And so I think you're seeing some very talented people taking over these roles. They're really becoming the conduit, if you will, or the way you introduce these tools into the business. They've got the skill set around analyzing the data. They've got the very good at working with management teams so that they can help the introduction. So I think you see a lot of them kind of move into that more general role as opposed to just analyzing existing processes. I think they're also doing a much bigger job.
Yeah, we also believe in that. I think we believe that the operational excellence would be the counterparty who can effectively master these tools. Because one of the big things we are about is explainable AI, because we don't want AI to become a black box for the industry. And that explainability of the AI needs to be transferred from IntelliSense to people who become champions of these technologies within their operations. So I will take the last question. I will say there is a last question which is linked to the thing that is very close to the heart for IntelliSense, which is all about value delivery, benefit tracking. So Mark, I will give you the last question. And one of the questions is, in terms of benefit tracking, can you further explain the meaning of before IntelliSense and with IntelliSense?
Yep, no problem. So when we talk about our value driver and the recommendations we provide, all of those recommendations are saved in real time in a historian. And so what we end up with is how a mine, this is looking historically, how a mine would have run with IntelliSense, with the optimized state at that point in time, and then the actual state. And so what I was comparing there was what was possible for that mine based upon a simulated future at any point in time, and then without it. So that's the difference between the two columns.
Okay, one of the things of the technology platform that we built, it's underpinned by a simulation platform. So we fondly call it time machine. So we are able to go back in time and see at that operating condition what could have been possible compared to what the operator actually did or the control system actually did. So that's a fantastic way to look at what we call opportunity lost or opportunity maximization that can be achieved.
Correct.
Now, I'm conscious of time. There's a couple of minutes left. Thanks, Mark. Thanks, everyone. I just want to wrap it up. We heard today the amazing work that the IntelliSense, our team is doing and bringing real world AI applications to the mining industry. We are completely dedicated to bringing AI technology for usable applications targeting different parts of the mining value chain. We looked at how we're deploying them at scale at our customers and the value they're getting. And we heard the value that deep sight and process knowledge can bring as complement to the AI technologies. And then finally, the new business model that is required for making sure these AI technologies are delivering value on a continuous basis, because continuous variability is a fact of life in mining. So as we close this forum, I want to announce that for the first time, we are going to do a follow-on of Inspirations this year. So in October, we're going to do a follow-on for Inspiration with a very focused on the technologies part. So we call it a tech fest, but the idea is we would bring in people who are actually building these technologies. We would give some hands-on access to ways to play around with some of the parts of our technology. It would be very interactive. And at the end, it will also talk about how we are deploying and running it at scale. So these are the key parts. So watch out for our next event in the series for Inspirations. And thank you for your time today. I really appreciate you making the time, taking an hour of your day, and look forward to seeing you in the next Inspirations. Thank you very much.